Okay, class, so welcome. And so what we're going to do today is we are going to talk about different types of lines, okay, graphs as linear functions, and we're going to talk about vertical equations, equations of lines, so vertical, horizontal, parallel, and perpendicular, okay? So that's what we're going to talk about. Okay, so if we look here, we have the definitions that I'm going to go over, and I'm going to explain here. So the equations of vertical lines, okay? These are the equations of vertical lines. So if we have a vertical line, and again, this is going to be similar to what we already I mentioned earlier. So this is going to be kind of a review, but now I'm going to formally state what we're doing here. So equations of vertical lines. So an equation of the vertical line through the point AB is always going to be x equals a. Okay, then I discussed that before in a previous video. Okay, so it's always going to be in the form x equals a. A horizontal line, so the equation of a horizontal line is that goes through the point AB is going to be y equals b. Okay, so again, y is not changing because it's horizontal. In this case here, for a vertical line, a is not changing. So x equal a is the equation of a line. Okay, so these are going to special examples for an equation of a straight line. So, okay. Parallel lines. Okay, so this is new. Okay, so one thing, since we've dealt with equations of a line, we're talking about like the point-slope form and the slope-intercept form of a line. So with the slope form, we know that every line has a slope, a straight line has a slope. So what we can also say is, hey, parallel lines are two distinct lines that have the same slope. Okay? Two distinct lines that have the same slope. Now, when we say the word distinct, that means they're going to have different y-intercepts. Okay, because if they have the same intercept and the same slope, then they're essentially the same line. Okay, it's just one line right on top of another. So when they say two distinct non-vertical lines, because why non-vertical? Because if they're vertical lines, then they're automatically going to be parallel to each other. Okay, all vertical lines are parallel. Okay, so when we talk about non-vertical lines though, oh, the other reason too is that we don't know the slope, right? The slope for vertical lines are undefined. So that's the other reason why we can't really use this definition. But again, vertical lines are always parallel, okay, because they have the same slope, okay? It's just, we can't calculate it, it's undefined. Okay, so for any non-vertical lines though, we can look at the slopes of those two lines, and if the slopes are the same, then they are parallel. If the slopes are different, then they're not parallel. Okay? Also, this is the shorthand for if and only if. IFF is short for if and only if, and because we're dealing with definitions, so I just shorthand it to IFF. Okay, so now perpendicular lines. Now perpendicular lines are lines that cross or intersect at right angles. Okay, so how can we decide or determine whether two straight lines that intersect are intersecting at right angles? Well, if their product of their slopes is equal to -1. So if we take the product of their two slopes and we get a product that's equal to -1, then the two lines are perpendicular. Okay, if the product is anything else, then they're not perpendicular. Okay, now what else does that mean? Well, that also means that the two slopes are negative reciprocals of each other. What does it mean to be negative reciprocal? It means that, well, one is a reciprocal of the other, but not only that, but if we have A over B, right, so that's one slope, and so the other slope would have to be the negative reciprocal. So reciprocal means we're flipping them, and then a negative means we're taking the negative back. And so if we multiply these two slopes, if you will, we get what? We get negative AB over AB, which gives us -1. Okay? And so that's what we're testing. So if we multiply the slopes and we get -1, then they're perpendicular. Or if we notice that the two slopes are negative reciprocals of each other, then they're also perpendicular. Okay, and that's it. So this is the introduction. These are the definitions. So again, we're going to do some examples on the next video, and we're going to go through and see how this all plays out as far as using these definitions. Okay, have a great day.